All right, let's get back to the proofs, and I want to take our angle proof. I want to take our angle proofs one step longer. Okay, one step longer. Look at my proof statement. Forget the givens. All right, it's a parallelogram. Great. Look at my proof statement. I'm asking you to prove sides are in the same ratio. That's what the proof statement is asking me. Hey, prove to me those sides are in the same ratio. But question: the sides aren't in the same ratio unless I would know what about triangles. No, that's not what we're using this unit. They're similar. Sides are not in a ratio unless the triangles are similar, so that's what I need to do first, or you're going to do in your group first. Before we do that, though, whoa, wait, I'm confused. I see one triangle. I see a second triangle. I see a third triangle. How do I know which one's the proof similar? Or do I just guess and hopefully I'm right? Is there anything up here that can help me say, hey, maybe you want to prove these triangles similar? Scott, go. Everyone look at your proof statement right now. Look at the proof statement. What's the first side that's showing? Top left. What's the first side? Now everyone look at your diagram. CE. Can you find a triangle that has CE as a full side? Yeah. CED. So there's triangle number one. Keep reading. What's another side in that proportion you're trying to prove? DE, which I already highlighted. Give me another one. BE. All right. Look at BE. Is BE a full side in a triangle you can find? BEF. Yep. So I think we found the two triangles we need to prove similar. Now that's on you and your group. All right. Angle. Okay. Angle. Jackson, if you want to join the group behind you, that's fine. All right. Here we go. Angle. Get it. Find two pairs of angles. I'm only going to give you about 2 minutes. Find two pairs of angles in those triangles that are congruent. Where are the two pairs of congruent angles? Let's see, I put those in my proof already. I'm sure we got that. It was vertical angles. Where was the other pair of angles that were congruent then? Hold on. I'm not going to do it that way. Okay, here we go. 13. Where was the other pair of vertical angles? Oh, yeah. Well, there was the other pair of congruent angles. No 13 today?
DC parallel to AF.
Okay, DC parallel to, now I would take AB or AF. It's fine either way. I'll take either AB or AF. How'd you know it was parallel, Cal?
Parallelogram implies opposite sides.
Good, that's a parallelogram property from last unit. Parallelogram implies opposite sides parallel. And then go ahead, keep going. How do you get your angles now?
Angle CDF can go to angle F because parallel line
Yep.
implies alternate interior congruent.
Okay, so you did CD. Okay, so Callum chose CDF congruent to F. Anybody have angle C congruent to CBF? Because that's also another pair of alternate interior angles. So don't change it if you had the other pair. All right, so again, angle CDF congruent to angle F. Or you had the other pair, which is fine. Parallel lines imply alternate interior angles congruent. Perfect. And now we have angle. This time, though, you got to create your own statement, right? Don't just copy it like last night. Triangle DCE, similar to, let's see if I go DCE, I got to go BFBE. Angle. Everyone have the similar sign, tilde, not the congruent. We're getting out of that habit, hopefully quick. Any issues up to here? All right, you proved them similar. Now you know the sides are in proportion, right? Triangles are similar. Corresponding sides are in proportion. So CE over DE is now equal to BE over FE. And here comes your new reason. It's kind of like the cousin. Remember CPCTC? After you prove triangles congruent, then the sides and angles were equal. Kind of like its cousin. It's up at the top if you want to write it in the box, but I'm going to use the shorthand. Corresponding sides in similar triangles are proportional. CSSTP. Corresponding sides, similar triangles, proportional. So there's the one-step extension to our proofs today. Anything? Because you're going to go back to your groups and work a little more. All right, let's go. Again, I'm not bogging you down with proofs. We only need to do 2 and we're good. All right, before I let you go in your groups, what you probably don't like is the proof statement. It's written a little differently than what you're used to. Hey, FC to DB, that's just a ratio. How else could I write it? FC over DB equals, same thing here. I can rewrite this as AC over PB. Just 2 different ways to write a ratio. All right, I am totally going hands off here. You and your group right now, find the because there's a lot of triangles here. Find the triangles you need to prove similar, prove them similar, and then show me CSSTP. I'll be walking around taking a look. All right, find the triangles first that you need to prove similar. Do so. Find angle. All right, let's talk where your angles should be now. I know where the triangles are. Now I got to find my angles. Each triangle should have a right angle. Let me first start with angle PDB is a right angle. Perpendicular lines form right angles. Okay, perpendicular lines form right angles. Separate step, AFC is a right angle. Definition of an altitude. Remember, altitudes form right angles from the vertex. Now you say they're congruent. So those are 3 steps right there. One is a right angle, perpendicular lines form right angles. The second one's a right angle, definition of an altitude, and then they're congruent. We're okay? There's A. Now your second A in angle comes from, this is a isosceles triangle. And what's across from the congruent sides? Angle B, congruent to angle ACF. Angle B, congruent to angle ACF. You could say isosceles triangle implies base angles are equal. You could also do in a triangle, congruent angles are across from congruent sides. Say the triangles are similar by angle, CSSTP. So if you got to finish up your proof, finish it up now before we go to an algebra problem. Make sure you got all the necessary steps, the right angles. You need to say each angle is a right angle in each step, not in the same step. Questions here? All right, you guys are seeing you're doing a lot of this on your own here. All right, another one of these triangle problems. First thing I want you to do, don't solve it, please. Don't solve it. Set up a good proportion in your group right now. That matches up corresponding sides. Set up a good proportion in your group right now. Don't solve it, though. We're going to solve it together.
I got that first time. Yeah.
Go ahead and get a proportion.
Right, yeah, it's that, but would it be like 2x minus 2 or 2x minus 2?
I think it's 2x minus. Yeah.
You're adding
Oh.
right, here we go. I'll put up my version up here up on the board. So I start with the sides and the two smaller triangles, x minus 1 and 4, and I try to match them up. 4 matched up with x plus 3. X minus 1 matched up with side CF. So I got to say to myself, all right, how long is side CF? Combine your like terms. X, and then I have 2 minus 1, which gives me plus 1. Please make sure we are cross-multiplying the same things before we move on. Make sure we're cross-multiplying the same things. All right, go back to work. Cross-multiply, set it equal to 0, and we'll get back and talk. Cross-multiply, set it equal to 0. I got to make sure you can do this algebra. Cross-multiply, set it equal to 0. Here we go. And then I'll take over from there. Because there's going to be a problem. Can't just do the first two and the last two. Got to distribute the x. Got to distribute the negative 1. Can't just do first two and last two. And once you get it equal to 0, you can just stare at it, and then we'll take over here in a second.
Oh, you are. Yeah.
Move everything over, get it equal to 0.
Oh, no, yeah.
All right, so up on the board, I cross-multiplied, set them equal. So that's what I end up getting. Again, hopefully we're good here. I got to double distribute. Here, 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 and here. All right, I'm going to move everything over, set it equal to 0 now, and hopefully we'll all be at the same spot. X squared minus 2x minus 7 equals 0 when I set it equal to 0. We all in the same spot? All right, now, if this was on last night's homework, you say, hey, do I know two numbers that multiply to negative 7 and add to negative 2? Multiply to negative 7 and add to negative 2. Anybody thinking of any? Because we'll be here for a while. Because there are none. Okay, there are no numbers. So this cannot be factored. So let's go back to day 1 and day 2. If it can't be factored, yes, I need to use quadratic formula to solve for x. I will give that to you on Thursday's quiz. Here it is again, negative b plus or minus b squared minus 4ac all over 2a. I'll give that to you on Thursday. No need to memorize it. Ready? What's my a value? 1. B value. Negative 2. C value. Negative 7. All right, let's one at a time here. What's getting plugged in for negative b? Negative 2 is b. What's negative b? Positive 2. Take a look. Plus or minus. Now you know my deal here. We're not going to plug in for b, a, and c. You're going to let your calculator store it. So let's go back to the calcs. Reminder on how to store. 1. Hit the store key right next to it. We remember where a was, right above math. Alpha a. What was my b value? Negative 2. Store it in for b. And my c value? -7 stored in for C. And now we ask the calculator to do what? B squared minus 4AC. 32. So we should all be getting the number 32 underneath the radical. All over, what should go in the bottom of the denominator? 2 times your A value. 2. Notice what the direction said. Simplest radical form. So that means take 32 and let's break it down. If you haven't done so already, go ahead in your group. Take radical 32 and break it down for me. Biggest one. I know 4 goes into it, but 4 is not the biggest perfect square. Keep going. Keep going. 4 is not the biggest perfect square.
Yeah.
Then you would get plus minus 2.
So it only went out of radical.
So everyone got 16 and 2? Breaks down into 4 radical 2. Go ahead and replace it. 2 plus or minus 4 radical 2 over 2. That's still not simplest form, though, because I could still divide. Here's where I'm worried about. Everyone see the 2 in the denominator. You need to apply it to the left and the right of the plus or minus. Not just one and not the other. So, 2 over 2. 1. 4 over 2. Plus or minus 2. No, I don't divide the radical. It's underneath the radical, I don't touch it. I can't divide it by 2. So it's just 4 over 2, which gives me the 2 radical 2. Questions here, how I got to this part. This is simplest radical form. Not my final answer. Not my final answer. Here's why. How many answers is this? It's actually 2 answers, isn't it? Ready? It's actually 1 plus 2 radical 2. And it's also an answer of 1 minus 2 radical 2. Everyone grab your calculator. Do 1 minus 2 radical 2. One of the answers I got. I'll do it with you. 1 minus 2 radical 2. That's that answer. That's one of your answers. Anybody got a problem with that being one of your answers? It's negative. And look at your diagram. Everyone look at your diagram right now. If you plug that answer for side AF, what's going to happen? That's a negative length, and we can't have that. So what am I trying to tell you here? What do we need to do with that answer? Yeah, reject it. Even when you use quadratic formula, you might have to reject an answer. All right, so we are going to have to reject 1 minus 2 radical 2. So there's only one answer, which is 1 plus 2 radical 2. Okay? You do have to check both still, even though we did quadratic formula. All right, I'm going to let you go on your own, but I do want you to flip over to the homework real quick. On number 1, again, you're going to set up a proportion, probably use quadratic formula. Before you do that, how did I just change the directions, though? Yeah, not in simplest radical form, but to the nearest tenth. So here's what you'll do. See our problem we just did? All right, so if I said now go to the nearest tenth, I go to my calculator, 1 plus 2 radical 2, and you know what I do to this number? Round to the nearest tenth. So you're still doing the same exact procedure, except at the end, you're going to go to your calculator, find out the decimal, round to the nearest tenth, and maybe reject. All right, go ahead in your group. Just pay attention to the directions.